Yes. So over here we have done trend test split. Now,
Yes, sir.
uh, now it's like now next step is model selection. So what you do, restart and run all the cells that we have. So where is that option? Yeah, this one. Uh, and once it is done, yeah, it's done. Now in Excel, write model is equal to model.
Model.
Yeah,
Plural.
model
Mhm.
is equal to give space. Yeah, and write capital L, and now press tab. Press tab. The button which is
Yes,
there
sir.
above caps lock. The button which is there above caps lock. Yeah, and it's not okay. So go to your first cell.
Mhm.
Go to the first cell. Actually, we have implement. Um, we have imported logistic regression in line number 5, right?
Yes, sir.
Now scroll down.
Yes.
So delete this logistic whatever you have done. Model is equal to after that delete whatever we have and write capital L. Model is equal to capital L,
Mhm. Tab.
then LO,
Hmm? Lookup
L,
error.
not this. Right, logistic regression you have to write. So capital LO
Okay.
GI and press tab. It's still not coming.
No, sir.
Logistic, then don't give space after logistic. Write capital R, and write regression then. REGRESSION. I've given spelling in the chat. Please check that. Yes. Now after regression, open and close round bracket. After regression, open and close round bracket. And run this cell. Yes. Logistic regression is not defined. What you
Yes,
do,
sir.
so just scroll down, scroll up, go to your first cell and run first cell only. So run this cell, first one. Yeah, it's running. Just wait. It's still running. There is star mark,
Yes,
right?
sir.
Yeah,
Yes.
now it's
Okay.
running.
Yes.
Go to last cell now. Go to last cell that we have, and over here, run this now. Yeah, it's important now. Now in next cell, I'm giving you command. So next step is for model fitting. So we are fitting our model in by using X train and Y train. So copy this step and paste it over there. Okay, you have not done restart and run all. That's the reason. Yes, restart. Yeah. Previously I've selected that continue running, right?
Yes, sir.
Yeah, that's the reason it wasn't completed. Mm, you're just restarting your kernel. Select that option besides that. Whatever you're selecting, na, उसके right hand side में, yeah. This is for restart and run all. Yeah, select that and restart and run also. So this is the option for restarting and running all the cells.
Run all. Okay.
Yeah, now go to your last cell. Yes. So we have fitted our model. Now it's time to predict. So model prediction. So copy this. Yes, and paste it over there. Now run this.
Okay.
Now check what we have in our y pred. So write y underscore pred in next cell. Y underscore pred.
Underscore head.
Pred.
Okay.
Whatever we have written in cell number 20, that we are checking.
Okay.
Yes. Now hit and enter. I mean shift enter. Yeah. Yes. So this is our y pred. Whatever we have in our y pred. Now what we'll do? Give heading as model evaluation. Model evaluation. And you have to give this as your heading. So change this to markdown and give level 2 heading.
Okay.
Yeah. Now run this cell and in next cell copy this thing. So we are finding accuracy score. Then we are going to find confusion matrix. Then we are going to find this thing.
Accuracy 78.0.783.
Yes. Now copy the next command that I've given.
Should I run it?
Yeah, run it. So this is our confusion matrix for now. Copy next command for F1 score. Yes. So this is our F1 score. And yesterday I've given you one homework, right? To read
Yes,
about.
sir. Confusion matrix.
Yes. So have you done that?
Yes, sir. Confusion matrix is used to predict confusion value. It will predict the predicted value and the actual value.
Yes. So what are the components that are actually present in confusion matrix?
Uh, uh, it have a uh, po- truly positive, truly
Yeah. Yeah.
negative,
Yes.
uh, negative positive, and a negative.
No, it's
Uh,
false positive and
mean
false negative.
false positive and false negative.
Negative. Right. Right. So we have four elements basically that are present in our confusion matrix. So in our columns we have predicted one, and in our rows we have actual
Rows,
value.
it is a actual values.
So we'll see one quick videos for this. I'll share my screen.
Okay, sir.
And what about this thing, F1 score and accuracy score?
Uh, it's, like I was doing now.
What?
Nothing, sir.
So see this thing. Mm, 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 mm. So for suppose we have this problem statement, right? We are finding whether
Yes, sir.
person has diabetes or not. So this is somewhat similar to what is our problem statement. So we have this actual value, we have this predicted value. So in this thing, in our columns, we have the person has heart disease or not, and then person does not have heart disease. In our
No, does
predicted value, person has heart disease and person does not have
does
heart
not
disease.
have heart disease.
Yes. So this
It is not audible actually.
uh, you're not getting sound.
No, sir.
Okay.
Identified by the algorithm.
Okay.
The true negatives are in the bottom right-hand corner. These are patients that did not have heart disease that were correctly identified by the algorithm. The bottom left-hand corner contains false negatives. False negatives are when a patient has heart disease, but the algorithm said they didn't. Lastly, the top right-hand corner contains false positives. False positives are patients that do not have heart disease, but the algorithm says they do.
So what is false positive? In actuality, person does not have heart disease, but in our predicted
It is
in our model, which has predicted, it
as a
has
positive.
yeah.
It is
So it is
also true. It is
yes.
also
So
true and it is predicted positive. But in the second corner, it is predicted as a positive, but the patient does not have heart disease. That's why it is
yeah.
false positive. Where in the
Yes.
third case, false negative, uh, it is predicted negative, but the patient is positive. And in the fourth case, it is predicted both negative and patient doesn't have heart disease.
So basically, it has predicted right. So these two values
Yes,
that are shown in green color, these two
uh,
these two
true values. True
are
values.
correctly
I
predicted.
mean, yeah.
These are patients that when 42 true positive
Um,
correct the random forest confusion matrix.
so this is about confusion matrix. Now we'll see F1 score and accuracy. Accuracy.
In this video, we will go over F1 score wrong. So those are called false positive. Yeah, is a word of three. Any of your
Yeah. So see this thing. Um, see these are our picture that we have already, and our model is what our model is to predict whether the image is of dog or not. So
Okay.
this is our model. This is our problem statement. So see this for this image it has predicted dog. For this image
Yes.
which is car actually, but it has predicted
Wrong.
dog. So like that it has predicted. So see this is wrong. Then this
Yes.
thing also wrong.
Wrong.
Then this image is also it has predicted wrong.
It's
And
right.
this
Sir.
image also it has predicted wrong. Yeah, right.
It is
It's
right,
right.
sir. Yeah.
Yes, yes.
Mobile
But this
is
is
wrong.
wrong. And this is
Yes,
also
sir.
wrong. This one
Wrong.
is also wrong. So how
Wrong.
many we got right over here? See, 1,
1,
2,
2, 3, 4, 5.
3, 4, 5. So out of 10 prediction that we have, our model has predicted 5 predicted
5 correct.
5 parameters or 5 things which are correct. So accuracy is nothing but the correct prediction upon total thing.
Total outcome.
So our accuracy is 0.
Predictions.
Excuse me, sir.
Can you
Wait a
get
bit.
the node
1 minute. 1 sec.
1, 2, 3, 4, 5. And total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Hello?
Yeah.
No, it's clear, sir.
Okay.
to
Now see this thing. How to consider, how to categorize our thing as true positive. Now see this. True positive means model has predicted correct thing. So this is correct as this is dog and model has predicted dog. So 1,
Yes.
this one is corrected 2, this is correct 3,
3.
and this is correct 4.
And this is 4.
So true positive we have 4. False positive means uh, model has predicted, actually it was there but model has predicted false. So this is false positive. This one is also false positive because model has predicted right. This is dog.
Yes.
This 1, 2, and 3. So we have 3 false positive and we have 4 true positive.
only take those out of yours 4 and
So precision is what? So we have another concept known as precision. It is out of all
Precision
dog
is out of
prediction. How many you got it
How
right?
many you got it?
So out of dog prediction, 1, 2, 3, 4, 5,
4,
6,
5,
7.
6, 7. Out of 7,
Out of
4
7
are
we
right
have
and
4. 4 right, na?
Yes, sir.
So 4 upon
is
7.
so it is 4 by 7.
So precision.
So you have
4 by
total
7.
7 but only 7.
So this is known as precision. What out of all correct prediction or out of all dog prediction, how many our model got right? So this is known as precision. So its formula goes like this: true positive upon true positive plus false positive. So basically, it plays with positive things only. True positive
Okay.
upon true positive plus false positive.
False positive.
Now we have total dog truth samples is equal to 6. So 3. Yeah. So how many samples we have? 1, 2,
2,
3, 4,
4.
5. I mean, how many dogs are there? See,
6.
images. 6 dogs are there, right?
4,
Which are
5, 6.
this one?
1, 2, 3,
Now let's talk
6,
about
sir.
recall.
Yeah.
So the
We have 6 that are supposed to be right, but actually our model has predicted 4 right.
4 right.
1, 2, 3, and
when
4.
you're thinking in my truth total 6 samples are dog samples, okay, but when I predicted only I got 4 as correct predictions for dog. So recall is out of all your dog truth samples, how many you got right? So you had total 6 dog samples. Out of that, you got 4 right. Hence, 4 divided by 6.67 is your recall. Okay, so recall is basically here's my truth. Okay, and in my truth I have 6 dog samples. Out of that, how many we are able to predict correctly. So now precision recall has subtle difference, which is when you're thinking about precision, always think about predictions as your baseline. When you're thinking about recall, think about truth as your base. Now let's talk about the negative class. So by the way, precision and recall is for individual class. So the previously what we saw was precision and recall for dog class. Now we are seeing precision and recall for not a dog class. So in not a dog class, precision is 1 by 3, because when you're thinking about precision, you're always thinking about predictions. So it's like, how many predictions do I have for no dog class? Well, 3. And how many of them are correct predictions? Well, 1. So 1 by 3, 0.33. When you think about recall, okay, pause this video, try to guess what will be your recall. For recall, you think about truth is your baseline. Okay, so what is my truth? All right, in my truth, how many no dog samples I have? Well, 1, 2, 3, 4. And how many of them I got right? Well, only 1. See, there is a green check mark here. So out of 4 no dog images I had, I was able to predict only 1 image correctly. That's why 1 by 4 is point.
So what is recall? Recall means out of how many
Out
samples
of
we have for how many
non-dog
samples we have for
samples.
no dog. This is one, this is another, this is
2,
another, and this is.
3.
So total we have 4 samples which are not of dog, right?
Yes.
And out of that, only one.
We predicted only 1 as a non-dog.
Yeah. So basically, recall plays with negative thing, that is negative, and
Okay.
precision plays with positive,
Positive.
true positive or false positive, and recall plays with true negative and false.
False positive and false negative.
No, true negative and false negative.
True negative and false.
Yeah.
Well,
So
whatever.
yes. Then we have F1 score basically, and that is nothing but the harmonic mean of precision and recall. So what is harmonic mean? It is two times the mean of. So this is formula for
2
harmonic.
times the
2 into precision into recall upon precision plus recall.
recall. Okay.
This is the formula for it. Basically, it takes into account both these things, both these concepts. That is precision and recall.
By
So
precision plus recall is 2 into precision into recall divided by precision plus recall. It is just a harmonic mean of precision and recall. It just gives you the overall health or overall performance of your model. So now we are going to write some code in Python to check all these things. Okay, so I have imported some libraries in my Jupyter notebook, and I have written this function. Actually, this function I have sourced it from this gist. So thank you for whoever wrote this function, and it will just plot a confusion matrix. Confusion matrix is
that's it all about precision recall, F1 score, and precision recall and F1 score and confusion method. So these are the things that we have. Now share your screen. Yes. So we have achieved our accuracy as 78% and our F1 score as 66%.
Yes.
So this is this is for logistic regression. So in this way we have completed this logistic regression.
Okay.
Our model has predicted by using much logistic regression algorithm. So next thing we'll see is decision tree. So
Decision.
save this.
Save. Okay.
Yeah, go to file and save. Save and checkpoint. Control.
Checkpoint.
Yes. Now go to your logistic regression folder. Tab number 3. and go back, click on Jupyter, click on Jupyter. Yes, over here, create new folder, new folder, and go to the untitled folder. Go to untitled folder. I mean, we have to rename that. So go back,
Sorry.
go back, go back. We have to rename that untitled folder. So how to rename? Yes, select that, scroll up, select that, scroll up, and see the rename option is there, right? Rename move.
Yes, sir.
Yeah, give name as decision tree. Decision tree. It would be better if we give D is equal D capital and T capital.
Okay.
Decision tree. Yes. Now rename this and open the folder. Open decision tree folder. It's above only D. Above.
Okay.
See decision tree. Yes. Now over here upload the file that we have. So you have to upload the same file for diabetes data. So
This one.
yes. Upload and create new Python notebook. So go new Python 3. Yeah. And
So
now we will implement decision tree algorithm. So in your first
should I
cell,
change?
yeah, you can give name as decision tree algorithm on diabetes dataset. I'll give you name for chat. So decision tree algorithm on diabetes dataset. Yes. Yeah. Now give heading as in cell number 1. Give heading as importing necessary libraries. Importing necessary libraries. LIBRA LIBRAREIS. Yeah. Change this. Change this to change this into Markdown. Markdown. So no, level 2 heading. Yeah. Run this cell and copy the comments that have given in chat. So these are the basic libraries that we are going to use. So all the libraries would remain same, but we will change our model into decision tree. So as this is a classifier example, so we will use decision tree classifier. Now read dataset. How we generally read our dataset.
Read dot.
But we have to store it in df variable, na?
Yes, sir.
So df is equal to pd dot read underscore don't give space. We don't give space in between the lines. So what is the extension of that file? It was CSV, right?
CSV.
CSV, and open and close round bracket, in round bracket,
Insert
import,
quotes.
right? PIMA. So right, P for, yeah. Now you can press tab. Yes. Run this cell now. Run this cell. Check head of your data set. So head, how we check our head? So div dot head. Yeah, perfect. So the problem statement remains same over here.
Yes.
Now you will explain what is our problem statement. What is our problem statement over here?
Mm,
Problem statement means what we are going to do in our data. So we have this data, right? This column.
diabetes.
Yeah. You're on correct track. What is that?
Analyzing the diabetes
We are predicting whether person
data.
has diabetes or not. So whether these persons that we have in our data, they have diabetes or not. So we are predicting that thing. So this is our problem statement. So you have to give this as heading.
Okay.
Yeah, run this cell. So whatever we are doing, that is df.info, df.describe. This is known as df.skew, df.kurt. So this is known as exploratory data analysis. So what you do in next cell, write df.info, df.info. Yes. Now what is next step after checking information?
Um, tail.
No, you can check the logistic regression folder that is open. You can check that for reference.
Logistic regression.
Open that logistic regression. Which is already open, right? You can open that. See the
Which
next tab
one?
we have. Next tab, logistic regression on diabetes data. Where is our next tab?
This one.
We have tabs open, right? WhatsApp, post attendee, Zoom, decision tree, then decision tree algorithm, and then logistic regression. Har Baba,
This
top,
one.
top. Where
Okay,
are our
okay. Logistic regression.
yeah? Open that
Okay.
and check what we have done after df.info. So these are our basic steps that you generally,
Describe.
yes. So after df.info, we do df.describe. df.describe. Now run this cell. In next cell, write df.skew. df.skew. Skew. Open and close round bracket. Now in next cell, write df.kurt. df.kurt. Open and close round bracket. Now run this cell. In next cell, write df.boxplot. df.boxplot. So these are the basic steps that we generally do for all the machine learning algorithms. So df.box plot in round bracket. So this is vertical box plot, right? We have
Yes,
to
sir.
change this to horizontal. So right in bracket of df.box plot in cell number 8,
Mm-hmm.
right? Vertical is equal to false. So VERT is equal to false.
False.
Capital F. Capital F. A L C. So if you give small f na, this green mark
Okay.
won't come. Now try giving small f. Try to use small f over there.
Okay. Okay. Okay.
Instead of capital F, try to use small f and run
Yes,
this
sir.
cell. Run this cell. It will throw an error. Again run.
Okay.
So false is not defined. So you have to write capital F or capital T for true.
Okay.
So this is less than 1 minute is
Horizontal.
required. I'm ending mid.
Yes.
You join with the same link.